Good morning, everyone. Thank you for joining us today. You know, over the past few weeks, we've gone deep into the whole stack of robotics. We started with that core sense, think, act architecture and went all the way to the absolute cutting edge, soft, swarming, and even bio-hybrid robots. So today, in our final capstone for this series, we're going to put it all together. We're stepping back from the individual technologies to ask a much, much bigger question about the future we're all building.
Right. We have spent so much time on the what and the how of automation. The incredible engineering, the mind-bending algorithms. But today, we're shifting our focus entirely to the why. What is the end game here? What's the ultimate purpose of all this tech? And what kind of world are we actually trying to create with these incredibly powerful tools? And just to be clear, this isn't science fiction. This is a real look at a future that's not just possible, but is already starting to take shape all around us.
So, here's the game plan for today. We're going to kick things off by looking at how automation's purpose is changing. Then, we'll dive into three huge pillars of this new vision: its role for our planet, for manufacturing, and of course in our daily lives. And then, and this part is absolutely critical, we'll talk about the choices, the very human choices, that we all have to make to get this right. So let's get started.
Okay, our first section really gets to the heart of it. For more than a century, automation has basically been about one thing: efficiency. But the challenges we're facing in the 21st century, they demand a totally new story.
You know, historically, the goal was simple. It was all about economic efficiency. Make more stuff, make it faster, and make it cheaper. That was the singular optimization function, period. But the challenges we're facing today are, well, they're existential. We're talking climate change, resource depletion, environmental damage on a massive scale. These huge, complex problems are forcing us to completely redefine the objective function for our technology. The next great wave of automation isn't going to be measured just by its economic output. It's going to be measured by its ability to help us build a more sustainable and a more resilient global society. We are literally shifting from optimizing for profit to optimizing for the planet.
And that leads us perfectly into our second section, which is all about that first massive pillar of this new purpose. How can things like robotics and AI become the essential tools we need to tackle our biggest environmental challenges head-on?
Well, let's think about our current economy. It's fundamentally linear. We take resources, we make something, and then we throw it away. It's a one-way street, and it leads to depleted resources and mountains of trash. The circular economy, on the other hand, is designed to eliminate waste entirely by keeping materials in a continuous loop. Now that sounds great, but it's a monumental logistics problem. You have to sort, disassemble, and reintegrate everything. And that is a challenge that's just perfectly suited for automation to solve at a massive scale.
So, how does this actually work? Well, it all starts with sorting. Imagine an AI system using advanced computer vision, maybe even hyperspectral imaging, that can identify and separate different materials with superhuman speed and accuracy. I mean, way beyond what any person could do. High-speed robotic arms then just pluck and place items into the right streams, which dramatically improves the quality of recycled materials. But the real game changer is automated disassembly. Think about your smartphone. It's packed with valuable rare earth metals. A robotic line, using precision vision and incredibly sensitive force-torque sensors, can carefully take that phone apart piece by piece, recovering those precious materials so they can be used in a brand new product. This is how we start to close the loop for real, on a global scale.
Okay, so the second planetary scale challenge is the energy transition. If we're serious about our climate goals, we have to build and maintain an insane amount of new infrastructure. Solar farms, wind turbines, battery plants, and often in really remote, tough environments. The sheer scale and speed that we need is it's beyond what our current human workforce can do. So automation isn't just a nice to have here, it is the only way we can actually get this done.
Let's look at some real applications. For construction, picture fleets of autonomous, GPS-guided vehicles just preparing the land for a massive solar farm. Then, specialized robots come in and install thousands of panels with perfect precision. For maintenance, imagine swarms of little robots cleaning every single solar panel at night to get the most energy out of them. Meanwhile, AI-powered drones are using thermal cameras to scan wind farms, and they can spot the heat signature of a failing bearing in a turbine gearbox long before it breaks down. This same idea of precision extends everywhere. To farming, where drones and autonomous tractors apply water and fertilizer only where they're needed, and even to protecting our ecosystems, with aquatic drones monitoring the health of coral reefs and LiDAR drones mapping forests to track deforestation.
All right, let's shift gears from the planet to the factory.
the very birthplace of modern automation, is on the verge of its own radical change, moving way beyond today's smart factory to something totally new.
The ultimate goal here is a fully autonomous, vertically integrated production system. And the best example of this is the modern Giga factory. The core idea, which Tesla has really championed, is that the factory itself is a product. In fact, it's maybe the most important product. The goal is to design the machine that builds the machine. And this is a huge mental shift. The factory stops being a building full of machines and becomes one single cohesive, self-optimizing machine.
The old way of doing things relied on these long, fragile supply chains and a very rigid, linear assembly line. The new paradigm is all about vertical integration, bringing as much production in-house as you can to get more control over quality and speed. And inside, it's like a symphony of automation. You have thousands of robots managed by a central manufacturing execution system, the MES, which is basically the factory's operating system. And instead of a fixed line, you have autonomous mobile robots, or AMRs, zipping around, moving parts and subassemblies between these dynamic, modular manufacturing cells.
So how does a machine this complex get better on its own? The secret sauce is the digital twin. Think of this as the factory's virtual brain. It's a complete, real-time digital replica of the physical factory that lives in the cloud and is constantly fed a fire hose of data from millions of industrial Internet of Things, or IIoT sensors, on every single robot, motor, and system on the floor.
And this creates this incredibly powerful, self-improving loop. The digital twin becomes a dynamic simulation where machine learning algorithms are constantly hunting for tiny optimizations. Maybe an AI finds that changing a conveyor's speed by a fraction of a percent or tweaking a robot's path just a little bit can boost the whole system's output. You get thousands of these continuous AI-driven tweaks, and they add up to massive productivity gains over time. The factory literally learns and improves itself, which gets us closer and closer to that ultimate vision of lights-out manufacturing, a facility that can run 24/7 with almost no human intervention.
Okay, so we've seen how automation can reshape our planet and how we make things. Now, let's pivot to where it has its most profound impact, how it's going to reshape the very fabric of our daily lives. This is honestly one of the biggest societal shifts of our century, and it is so much more than just self-driving cars. The real revolution is a seamless, integrated transportation network, what we call mobility as a service. Imagine you just summon a ride and the network automatically dispatches a little autonomous pod for a short trip, or it routes you to a high-speed shuttle for a longer journey. This could totally change personal car ownership, which would free up huge amounts of space in our cities that are currently just dedicated to parking. And check out this staggering statistic. Over 90% of all traffic accidents are caused by human error. A fully mature autonomous system where all the vehicles are connected and communicating with each other in a central traffic system could make our roads orders of magnitude safer. By coordinating all their movements, these systems could pretty much eliminate traffic jams. And for logistics, well, that means autonomous trucks moving goods around the clock, with delivery bots handling that final mile right to your door.
So as a lot of countries, including Canada, face this big demographic challenge of an aging population, automation can be a really powerful tool to improve quality of life. And the goal here is not to replace human caregivers. The goal is to augment them. Robots can handle all the strenuous, repetitive physical tasks, which frees up human time for what's really important: companionship and emotional support.
And we can really think about these robots in two categories that work together. First, you have assistive robots that provide physical help, helping a person get out of bed, being a smart medication dispenser, helping with chores around the house. And then you have social robots, which are designed specifically for companionship and cognitive stimulation. They can have conversations, play games, and make it super easy for users to connect with their families over video calls, becoming this vital link to the outside world.
You know, one of the most exciting impacts of all this is its potential to just accelerate the pace of science itself. A self-driving laboratory uses a closed loop of AI and robotics to automate the entire scientific process. So in fields like material science or drug discovery, an AI can hypothesize a new chemical compound that has some property you want. Then a robotic system automatically creates and tests it. The results get fed right back to the AI, which updates its models and designs the very next experiment. This loop can run 24/7, accelerating discovery at a rate that is just impossible for human teams.
And that brings us to our final and honestly our most important section. This whole vision of an autonomous planet, it's all technologically plausible. But, and this is a huge but, it is not inevitable.
Technology is just a tool. The world we build with it is our choice. And this transition comes with huge challenges, from labor displacement to the concentration of power. To navigate this successfully, we have to make a conscious effort in 3 key areas. First, we need a proactive public dialogue that includes everybody, not just the tech people. Second, we need agile and ethical governance, new frameworks for accountability and safety. And third, we need a just transition. That means deliberate policies, massive investment in reskilling, and stronger social safety nets to make sure the benefits of all this automation don't just widen the inequality gap.
So, let's wrap this up by summarizing the path from this grand vision to a reality we can all live in. The biggest challenge we face, it isn't a technical one. It's a human one.
So what's the bottom line here? The promise of automation is so much more than efficiency. It's a tool to build a more sustainable, resilient, and prosperous world for everyone. But, and here's the condition, getting there requires our conscious choice, ethical guidance, and inclusive policies. Real-world signals, from Tesla's Giga factories to NASA's Mars rovers, they prove this future is actually plausible. But it's a world we have to actively and consciously decide to build. I really hope you'll join us for our next series, where we are going to be diving deep into AI trust, risk, and security management.
And that, right there, is the ultimate challenge. This isn't about the code, it's not about the circuits. It is the challenge of deciding, together, what kind of future we want our incredible machines to help us build. Thank you so much for joining us today. Be sure to subscribe to our channel, Tech AI and Beyond, for more deep dives into the technologies shaping our world.